people, it's your favorite sensei again here, Teacher Mohau, and on today's lesson we will be doing an exam question of electric circuits, ne? So hope y'all are doing good and are ready. So let's buckle up, ne? So now we are given a question here. Says in the circuit below, we have unknown EMF, battery of unknown EMF, and internal resistance of 0.5. It's connected to two resistors for an 8 each, and a resistor R, unknown resistance. Now, okay, ignore the resistance of the connecting wires. So now the first question now before that, let's try to analyze what is happening here in the circuit. Ne? We know we have a circuit, we have this battery here. We don't know the EMF of the battery. We know V2, which is the voltmeter. So we know that the current will go this way, and yet if the current if the switch remains closed, and yet so we need to firstly do that so we can understand. And if the switch is open, we know that it will be now parallel, so it will be like this, ne? But for now, switches, let's just keep this one as it is. Now they tell us that the three external resistors are ohmic. Explain the difference, the meaning of ohmic conductor. Remember ohmic conductor. What are ohmic conductors? Ohmic conductors are conductors that obeys Ohm's law, ne? Remember Ohm's law, and here it states that basically the gist of or the summary of Ohm's law just tells us that the potential difference is directly proportional to the current, and yeah, so which means if the potential difference increases, the current will also increase, and yeah, the current will also increase. But if the resistance increases, the current will have to decrease, and yeah, so ohmic conductors are conductors that obeys Ohm's law, which means that they if in one of the resistances, in one of the conductors, if the potential difference increase, the current will increase, and yet but if they are not Ohm's law, which means they don't obey any of this here, which means they go by their own rules, if they are non-ohmic, which means they don't obey Ohm's law, and yet so which means that now if the current may increase on the non-ohmic conductor, the current may also increase, or the potential difference may also increase. It doesn't really matter. As long as they are non-ohmic, they do not obey Ohm's law, which is this, that potential difference and current are directly proportional and inversely proportional to the resistance. So it's just a brief explanation of ohmic conductors. So now they tell us the second question better. When switch S is opened, voltmeter 1 reads 2,1, 3,2. Now, let's firstly understand this. When switch S is opened, so at the top we do not have any other switch except for switch S. So if now the current is flowing in the external circuit, now this basically means that the voltmeter 1 reading is this voltmeter here. So we have to find the total current one here. We still know the same thing, that the same current that goes outside of the battery is the same current that will pass through here. It's also the same current that passes through the 8 ohm and the 4 ohm resistor. So now it's easy for us now to find the current of the battery if we know the voltage that is here. So you know the voltmeter 1, it was 3,2 volts. So now which means that now we know that the resistor now it's the 4 ohm resistor. So it's easy for us to find R because we know that it's V over R, which is 3,2 over 4, which gives us 0,8 amperes. So this is the total current. Basically it's the current, and you remember we know that in series their current is the same. So the current that is passing through here is the same current that passes through here, is the same current that goes in the battery. So in question number 1, current that goes across the battery is this particular one. Ne? So let's go to the second question. They're asking the EMF of the battery. The EMF of the battery. How are we going to find the EMF of the battery? Remember, first things first, what do we need to know? Ne? For the EMF of the battery, we need to know the external voltage and the internal voltage. But unfortunately now, we do not, for now, let's just do them like this. IR, which is the total R external, which are the resistance that are in series, which is this 2, which is the 8 one and the 4 one, and then R, and then we have our R resistor, internal resistance is 0.5. So now we just basically say EMF is equals to the IR, and we know this one is 0.8, so multiplied by, and yet these ones are in series. So if we want the total current, we know that we have just we just have to add them. So it's about the 4 plus the 8, it's about 12 plus 0.5, which if we add this is going to be 0.8 multiplied by 12.5. It will give us a sum of the product, which is 10. So that the EMF of the battery is equals to 10. So now let's attempt another question. So now basically here, it's basically knowing the total current. We know that if we find the total current, it will be easy for us to find the R external because they are only in series, and then we are also given the internal resistance. So we just substitute there to find our answer of the EMF. So now they're asking that now, they are telling us that now switch S is closed. I'm just gonna erase this. Switch S is closed, which means that now this path, there will be another path, which is this path here, because the current will now flow. So let's try to recap and remember what happens in series. We know that the current will divide. So the current and this one will divide to go to the other one. But and then also here's another thing that happens now. We know that what is added now, we adding a resistor in parallel. So now this affects now the current in the external circuit. It affects the current in the external circuit. So which means the current in the external circuit will no longer be 0.8. It will change. Why? Because of now, remember, according to Ohm's law, because of this ohmic conductors, if we add resistors, it will affect the current. The current will change. Either it will decrease or increase. So we know that if we are adding resistors in parallel, what happens is that if we add resistors in parallel, the current will also increase. Why increase? Because of resistors in parallel, remember, we just get it's a fraction, so they will just affect it positively. Instead of, if there were resistors in series, they were going to decrease the current. So the gist of it is just a matter of offering the parallel resistors that we adding, they will affect the current. So current total will no longer be 0.8. So which means we have to find the new current total. So whatever or the voltmeter 2 reading. Voltmeter 2 reading is the voltmeter here, which is 8.8. So voltmeter 2 reading here, now we know voltmeter 2 reading, it's the voltage external. So the V external area now, it's 8.8. Now they're asking us to find the resistor R. So resistor R, how are we going to find it? So first of all, let's try to draw a simplified drawing of this particular resistance if we know that we have resistors that are in parallel. It will be something like this. We know we have that one that is 12. Yeah, everything combined. And look at the internal resistance and the battery. Then we have the one LIR anger, which we are looking for. We know that the only resistors that we have now are the resistors in parallel, which is 12 and R. So we know that R parallel it's just 1 over 12 and 1 over R. So we have the external voltage now. We know it's 8,8 volts. But do we know the current or external current? No, we do not know the total current here. So which means, so first of all, we have to find the total current area first. We have to find the total current first so that we'll be able to find the resistor here. Why am I saying that? Because we know that the V external is equals to I times R external. So we know that the only resistors that we have key resistors in parallel. So we know that V external is R external times I, which is here it's R parallel multiplied by the current here. So we need to find the current first. So let's go back here and see. Okay, now they're telling us V2 is 8,8. So now what do we need to do first? We know that what happens is that now here they just added the thingy. They added a resistance. The battery is still the same battery. Battery is still the same. So battery EMF it's 10. V external it's how much? It's 8,8, which means that the V internal it's 10 minus 8,8, which is 1,2 volts. Now we know that the thing here is that for us to find the V internal, it's the I multiplied by R. And we are given this small r, which is equals to 0,5. So we know that it's now 1,2 I. Remember, we know that the current here, it's the same. Current here, it's the same current that is in the internal voltage. So we are looking for this. That is common also on this side. So this will be 0,5. We know that I is 1,2 divided by 0,5, which is 1 over 2 times 2, which is 2,4 amperes. So now we have found the total current, or it's 2,4 amperes. So we are going to use this 2,4 amperes here. Here, basically here, so that we can find the parallel the resistors. So now let's now continue. We have R V external, it's I times R external or R parallel. So this is 8,8 and this is 2,4 times R parallel. So we have to divide both sides here, which it will give us. So it's the answer, it's 3,67 ohms, which is the total R parallel. So now we have find the total R parallel. Mara, we know that because of we have an unknown, 1 over R parallel is equals to the 1 over the 12 ohm resistor, which is this one A, and that other missing one that we don't know we are looking for. So it's over 1 over r. Ne? So we know that when we add these things, they have to give us this. So now we know 1 over r parallel. Firstly, let's deal with the side pele so that we can make the denominators for debate the same. So 1 over 12 plus 1 over r. Let's treat r as a variable. We know that we have to make LCDs. LCD now it's 12r. So it's 12 times r. We multiply with both sides with the opposite. So it will here will give us 12 over r. So now it's 1 over r parallel arena. So now, which means that this r parallel, it's like vice versa of this one here. So 1 over r parallel, it's 12r over r plus 12. Why am I saying it's vice versa? Because of basically here we just have to do cross multiplication to find rp. It's like something like this. Let me just do it quick. It's rp, which is 12r. It's cross multiplying. This will be equals to 1 times 12r, which is 12r. So because we're looking for this at the start of the formula, we divide by 12r, this side also, which the answer will be left with is 12 over rp, which is this thing. Right? Let's erase here. So now, what else do we know? We know that this 1 over r parallel, it's equals to 3,67. So we just substitute here, we put 3,67 is equals to 12 r over r plus 12. So now, let's cross multiply again. So it will give us 1 times 12 over r, which is 12r, is equals to this times that. It's 3,67. Let's zoom in. R plus 12. So now here we know that now 3,67 times r, it's 3,67 r plus, here we know we have to factorize here. So the answer will be 12r is equals to 3,67r. We are factorizing. Then it's 3 multiplied by 12. 3,67 multiplied by 12. Let's use the calculator quickly. The answer multiplied by 12, it's 44. So now our answer is 44 plus 44. So then after that, we know like terms, our like terms, it's everything that has an r. So we take this to the other side. It's going to be 12r subtracted by 3,67r is equals to 44. Then let's find the answer of this. It will give us 8,33. 8,33r is equals to 44. So we divide both sides by 8,33, divide both sides here. Then now after that, this will cancel out, so we can find the specific value of the resistance R. So 44 divided by 8,33, let's do answer, divide by 8,33, answer is 5,28. So the answer is 5,280. So this is how we find the answer of the missing resistor that is unknown. Basically here, it's just a matter of using basically more or less like simultaneous equation, because of from this we substitute with the answer that we got, so it's like simultaneous equations here. So I hope you all enjoyed the video, and don't forget to like the video, to share the video, and to subscribe to our channel. See you in the next video. Bye bye.